Hi again. So in the blog this week I've been talking about how we will be able to treat wastewater in the future by using technology that has lower costs, higher efficiency and a lower footprint. If we can do this, then we'll be able to increase water reuse, which will become vital in the future given our increasing population and demand for water. I think that at this time we need to make use of membrane technology. This is widely available and less energy intensive than the traditional activated sludge process. It also has a much smaller footprint and hence I think it could be the start of using decentralised systems. Last week on our site visit to Subiaco Wastewater Treatment Plant, we were told that one of the highest costs that they incur is removing the sludge. With membrane technology, it's simply not an issue. I think that it's a short-term solution and ultimately I believe that the future of wastewater treatment and reuse lies with nanotechnology. So as I mentioned in the blog, there is a number of technologies that can actually be applied under the broad umbrella of nanotechnology. For example, nanomembranes. This technology is the same as traditional membrane technology, but with much smaller filters. This requires a lower pressure to operate, and hence would be ideal for treating wastewater to reusable standards with a lower energy requirement. Nanomagnets can also be used to attract large particles in the water that can block filters, hence increasing their efficiency and reducing blockages. As well as this, the systems are also really small and able to treat large volumes of water, so that would be ideal for the use in decentralised systems. So currently the technology is new and quite expensive, but in the future it's definitely something to think about. Another technique that I briefly mentioned is nanosorption. Iranian researchers were able to use this technique to treat wastewater from pharmaceutical plants. This is a large issue at the moment, being able to remove tiny particles from water, specifically particles coming from medication, before it enters the environment, because it can have serious consequences. For example, we've heard of fish changing genders due to increased hormones in water, which is a reduce of the use of the oral contraceptive pill. So essentially, nanosorption is when a particular nanoparticle is added to water, which attracts another particle, and hence removing this other particle from the water. The particles used in nanosorption can be rinsed and reused, leading to lower treatment costs. So these nanotechnology approaches are all highly effective at removing the bad things that we want from wastewater, and hence we can produce reusable water. If we were able to combine these technologies in some way to create a small system that could operate at someone's house, then we'll be able to reduce infrastructure costs and also increase reuse. It really is the way of the future, and I'm hoping to see it soon.